Appreciate y'all coming. What I've done, I posted this, and I'm sorry that it's a little bit late. In the future, I'll post it a day beforehand. But I posted all the exam 1 questions. Those are the questions that you should be preparing for the test. Don't try to memorize them all because there are hundreds of them, or at least 100, I think. But I would go through them and see that you know how to do them all. I think most of the stuff that y'all probably do know how to do, but some of the stuff that you might need to repeat a bit. So we can go through. If there are particular things that you want to look at, let me know. Are there particular topics? And we have the standards of mass, length, and time. That's what you need to know it. Okay, you need to know what the current standards are and what are the past standards and what makes a good standard. I just posted this on Moodle. You need to know your units and conversions. We did some of this today. On the exam, you'll definitely have units and conversions that are squared or are cubed. So you'll need to know how to handle those sorts of things. You'll need to know your trig. So these are the different topics that you'll see on the exam. You'll need to know how to use your trig functions, how to use the Pythagorean theorem, stuff that you've seen before. I know that you have, but it might have been a while, so you'll need to review that. But it's really important for vectors and coordinate systems, approximations. Students often have trouble with this. We can look at some of these questions. You'll get a feel for the things that I ask. Significant figures, you'll have a multi-step operation, and you have to tell me either how many sig figs or what is the appropriate answer for sig figs. And dimensional analysis, like we were doing today, is this equation dimensionally correct or not? Or what are the units of this unknown variable, the x equals AV, that kind of problem. And we can look at that. I think that's all the topics. Yeah, that's it. So those are all the topics from chapter 1. And that's all the topics that you'll see on the quiz. You won't see all those, of course, because there'll just be, I don't know, 7 or so questions, 5 to 10 questions on the quiz. What do you want to see first? Like, what is the hardest, in your opinion, of these topics? Yep. Approximations? Okay, yeah, that's what I was going to say. All right, so as I said, with approximations, you need to know those 3 measurements, the meter, the centimeter, and the kilogram. But then, and a kilogram is a few pounds. So you need to be able to look at a physical object and estimate what is its area, what is its volume, what is its length, or what is its mass, knowing what those 3 physical measurements are. So for example, here with your fingers together, what is the area of your hand? And when I was looking at that, I was thinking, well, your hand is approximately 10 centimeters across, and it's approximately twice that long, right? Your hand is about twice that long. So then that would give me 200 square centimeters. You follow me? About 10 centimeters across, 20 centimeters down, and so that would give me 200 square centimeters. But then notice that all my answers are in square meters. So then there's a unit conversion problem there as well. So then I would need to convert this to meters. There are 100 centimeters in 1 meter. Yes, y'all with me? I'll show you another way to do that. Remember, centi is 10 to the minus 2, which is the same as 1 over 100. So that's where the 100 comes from. Another conversion factor that you could have done, which is sort of more correct, is that you would use the conversion factor that there are 10 to the minus 2 meters in 1 centimeter. Those are the same, right? It's still 1 over 100. So when I do that, I have to square this. So that's 10 squared, 10 to the minus 4, 200. That's 0.02 meters squared. And so A is the right answer on that one. So there are 2 steps to that problem. I have to figure out what is the area of my hand, and it's easier to do that in centimeters, that I'm about 10 centimeters across, and I'm about twice that long, giving me 200 square centimeters. It will be like that. It'll be something that's right before you. Sometimes I just put a little piece, a square or something on the paper, and I ask you to analyze that, or I give you something in the room, something on your body, whatever, and ask you to find the area or volume of that. See, we did one like this, and actually number 3, the area of the projection screen. This one I was looking at one like this, that it's about, I don't know, 2 meters or 3 meters tall, and then about a little bit more than that wide. And so really the only reasonable answer for the area of this screen is 10 square meters. Because 1 square meter would be a screen that was about this big, a 1 by 1 screen. And a 100 square meter screen would be one like in Pelcha Auditorium, much, much bigger than this. So the only reasonable answer for the area of this screen is 10 square meters. You with me? Yeah? Let's look at some of these that are a little bit different. If an apartment has 1,100 square feet of floor space, how would you find the volume of the apartment? What do you need to do to find the volume? If you know the area of the floor, how do you find the volume? Cubits. No, cubit. You do what? Yeah, well, length times width is the area, and we have the area, which is 1,100, but we want to know the volume. What do we need to multiply by to get the volume? We need to multiply times the height. Right, so volume is length times width times height. I already know the length times width, that's 1,100. And the height, what is the height of your apartment, roughly? Anybody know? It's about 10 feet. I think it's really more like about 8 feet. So that's 8,800. That's about 10,000 cubic feet in your apartment, and 10,000 is 10 to the 4th cubic feet. Okay? These are the types of approximation questions that you'll see on the quiz and on the test. Pencil, how many meters long is a pencil? How many centimeters long is a pencil? Well, notice here that I have 2's, so it's going to be 20. It's not 200, it's not 2. A 200 centimeter pencil would be, about this long. A 2 centimeter pencil, and my son, he uses pencils that are like 2 centimeters long, but, that's not normal. A normal pencil is about 20 centimeters long. Okay? Want to do some dimensional analysis? Yeah? Let's look at those a little bit. Where were they? Standards of measurement, like I said, you just have to know them. We can come back and do unit conversions too. I'll do trig. Okay. Students often have trouble with this as well. On the exam, I usually have 2 to 3 questions that are dimensional analysis. You'll probably have one on the quiz too, because I think it's kind of important. Couple different classes of problems. You can have one like this, like number 2, where I want to know just what are the units of constant b. And so here I give you an equation. A is equal to b times x. And so I know that b is equal to a divided by x. And so if I want to know the dimensions of b, I would just solve it for b, and then I would put in my units. So a I know is meters per second squared. And then I have x is 1 over meters. I always like to separate it out, okay, because it just helps you to remember what's in the numerator and what's in the denominator. So notice that I pulled this x, which is a meter, I sort of pulled it out to the side. That will help you in the long run. That might seem obvious to you here, but when you get more complicated things, it'll help you to sort of separate the variables. Separate them like a over 1, 1 over x, like that. It will help you. And so the meters cancel, and I'm left with seconds to the minus 2. I like to give questions like this, where which of these are dimensionally correct or not. We can look at each of these. So this one actually is a little bit complicated, but let's take a look at each one. So this is sort of the second class of question where I just give you an equation and ask you, is it dimensionally correct or not? So let's look at this first one. The units of x are meters. The units of x are meters plus x squared over vt. So I have meters squared, and then I have 1 over v. That's going to be 1 over meters per second, and then 1 over seconds. Look, I'm going to rewrite this right here is not 1 over meters per second, but seconds over meters. Okay, did y'all see what I did there? I have this 1 over v right here. V is meters per second. 1 over meters per second. I just flip it. You will have to do that on the exam. So I know students sometimes have trouble with that, but it'll be greatly to your benefit if you can work with fractions really easily. Okay? For the future, not just for this course, but other courses too. Plus t squared, which is seconds squared. And then the square root of a squared, that's just a, right? So it's going to be a, which is meters per second squared. I can just get rid of this and say that's a. Whew. So I go through meters, meters, meters. That cancels. I'm left with meters all throughout. So far, this one is okay. As soon as I get that, let's go through and start looking at the options, okay? Because I know that my option has to include 1. So that gets rid of that one and that one. Okay? We can look, you don't know this right now, but after chapter 2, you will know that this one is not correct. Because we have an equation that's very, very similar. That's x equals x plus vt times vt squared. And you might actually be able to look at this and say a times t. That doesn't sit well because it's meters per second squared times seconds, which is going to give me meters per second. You might not be able to do that right now, so I'll write it down, but soon you will be able to. So let's write it out. I have meters equals meters plus meters per second squared times seconds plus meters per second times second squared. And I have issues all throughout here because I don't have meters in those second two terms. So this one is not included, but just take a quick look. That doesn't help me get rid of any answers. On this one, this next one, I want you to notice that I can get rid of my m's all throughout. That helps me a little bit. On number 3, I have meters per second squared meters plus meters per second, or equals rather, meters per second, but then that's squared, v squared, so it's meters squared per second squared, plus meters per second, that's the x over t. So it looks like this one is okay as well, because I have meters squared per second squared in every term. So that tells me that it has to be B is the answer. How do we feel about that? Did you get that question? Okay. You will with practice, okay? I know that about half of you probably get that question. Definitely you get it wrong today. But on the test, with practice, you will be able to get this, okay? This one's a little more complicated. This is probably one of the more complicated ones that I would give you. If I gave you this one, I would give you another one. I'm conscious of the time. But you also need to be conscious on the exams that you only have an hour. And so you got to know it in order to finish the exam in a time like that. I don't want to scare you, but I do want to scare you just a little bit. Okay? You scared just a little bit? Good. Be just a little bit scared. But, not all about the grade either. We want to learn how to do physics, and we want to learn the mathematical tools that are required. But I want you to make a good grade, too. All right. Did you see sort of, too, how I go through? That's just standardized test thing. That as I go through, I look at options along the way, and I start to get rid of options. And it greatly increases my likelihood of getting the right answer if I make reasonable choices. Okay. These are some similar ones, like I just did. Similar ones. These are all similar. Lots of practice here for you, okay? And these, there are solutions to all of these online, but they're sort of embedded into each exam. And what I've done here is I've just pulled all the questions from all of my banks and put them into one document for you to look at. It's on Moodle right now. I recommend that you print it out and you try to work through these on your own. Okay? I think those are the different classes of questions. Yeah, that's it. Just those two different classes of questions. You want to do another one? Want to do another one like this? Okay. This is number 24 in that one. After chapter 2, you'll be able to look at this one and tell me that this one is definitely correct, because this is one of our kinematics equations that we'll learn in chapter 2. Well, let's go ahead and do the dimensional analysis of this. I have meters per second equals meters per second. Remember this 0 subscript? I mentioned it in class today, and we'll see what that means in chapter 2. But for now, it doesn't mean anything. It really just means the initial velocity, but it still has the same units, so it doesn't affect the units at all. Plus A is meters per second squared, that's acceleration, times seconds over 1. That cancels, so this one is okay. This one, first, I can simplify it a little bit. I can get rid of the m's, I can get rid of this v with that v, and I can get rid of this x with one of these x's. So I'm left with that. And then you can probably look at that and tell good or not. Can you look at it yet? No, you can't. Let me write it out. So I have meters per second squared, that's A, equals meters per second times 1 over meters. Is that dimensionally correct? No. The meters cancel. I have meters per second squared on one side and 1 over seconds on the other side. So not dimensionally correct. Let's go through. So it can't be that one, and it can't be that one or that one. So it has to be either, oh, it can't be A either, right? Oh, no, I'm sorry. It would be B. Did I make a mistake? Oh, was it cubed? Oh, yeah, you're right. Yeah, so this would be V squared. Oh, shoot. So I have meters per second squared equals meters per second squared times 1 over meters. So that one is correct. And so that tells me that A is the right answer. That's another good point on the test, that you got to read it pretty carefully, right? If you're rushing through, if you're not careful, you're going to miss something like a 2 versus a 3, just like I did. But when I mess up, it doesn't dock my grade. But when you guys mess up, it does, okay? Like, they don't dock my pay when I miss a problem. But I do. Okay? It's going to be okay. Again, not mean to scare you, but I do want to scare you just a little bit. The first test is not the hardest test. Usually the second test is the hardest test. So that's also good news too. All right, let's look at our trig. Is that okay? Trig's really important. But if you know SOHCAHTOA, if you know the Pythagorean Theorem, you're going to be okay. Because I'm going to give you a figure that looks something like this, or I might describe it in words, kind of like the airplane today. And I ask you for either the angle, or I ask you for the side of the triangle. Look, special triangles, love special triangles. Who can tell me what x is in this triangle? 3. It's a 3, 4, 5 triangle. Love 3, 4, 5 triangles. The numbers work out really well. I don't want you messing around with numbers a lot, so I really prefer that you just be able to look at a triangle and say, oh, that's a 3, 4, 5 triangle. The MCAT too, by the way. They love special triangles too, so it's useful for you to know the special triangles. 3, 4, 5 I use a lot. So I can just tell you right off that that is a 3, 4, 5 triangle. Who knows what the angle theta is? No? Nobody? It's 53 degrees. So if you're preparing for the MCAT, it's useful just to know those angles. So the angle is 53 degrees, and I can find that if I just know this number and this number, which is all I'm given. That is the opposite over the hypotenuse, the opposite and the hypotenuse. So which trig function do I use? Sine, right. Remember, so, ka, to, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You need to know that because you'll have to use any one of those trig functions to figure out the unknown side or the unknown angle. And we'll use it a lot in the coming chapters and up until next year. Like we'll use that forever. So I say sine of theta is 4 over 5. And then theta is the inverse sine of 4 over 5. On your calculator, this is usually second sine. It's like sine to the minus 1. You might also say arc sine. That means the same thing. And that's 53 degrees, right? Do I get 53? Like 53.1 or something. Also, if you look at this triangle, I want you to notice that there are some answers that are just not reasonable. And which answers are not reasonable? 90 is not reasonable, right? Because this angle is 90. This angle has to be less than 90. What else? 10. 10 is not reasonable. Why is 10 not a reasonable answer? Other than you just looked at it and you said that's more than 10 degrees. Yeah, I think I heard you. Let me say what I think you said. That this angle is opposite the bigger side of the triangle. So this angle has to be bigger than this angle. And if it were 10 degrees, then this would have to be 80 degrees. But this angle has to be bigger than this angle. You see what I'm saying? This angle is bigger the opposite side. See, this is 3, this is 4. If theta is bigger the opposite side, it has to be the bigger of the two angles. And these two angles have to add up to be what? 90. Right. 180 is the entire triangle, and that includes this right angle right here. That's what you're thinking. Okay? Need to know your triangle. You need to know it backwards and forwards. If you don't remember that from trig, now's the time to get it. But the good news is it's not that complicated. Like y'all took trig or calc, knew what you did. You learned a lot of stuff in there. It helps you in the class because it helps you with your algebra. But a lot of the trigonometry we don't need. Like it's really just the right angle trigonometry that's useful for this class. All right. I don't think all of these are just like that. I just want you. Here's one like we did in class today, where I want you to know the origin. But in this case, all you do is recognize that this is a triangle. And this is a side that's 3 units long. This is a side that's 2 units long. So I say the square root of 3 squared plus 2 squared. That's square root of 13, which is what, 3.6? Yeah, 3.6. Pythagorean Theorem. You need to know that too. Not just, you'll have questions that are strictly trig, but they're also important for future tests. Every test that comes after this first one. Every test in the whole class, actually. It's very important. What didn't we do? Unit conversions? Let's do a hard unit conversion. Find one of the most difficult. Is this helpful for you people? Okay. If you have particular questions, this is a good time. I know I've been talking a lot, but it's a good time for us to ask questions. So usually in these help sessions, it's just sort of me going over stuff. And sometimes people will have particular things as we get deeper into the course. For the exam help session, we'll have a help session just prior to the exam, the 4 exams. Those are more driven by your questions because y'all are usually more prepared for questions. All right? Okay. Let's do this one. This one's not easy. I have a car accelerates at 10 meters per second squared. and I want to find the acceleration in kilometers per hour squared. So I say 10 meters per second squared, and already I need to recognize that I have a squared unit here, so I'm going to have to do something to the conversion factor because I want to convert it into hours squared. Let's do the meters first. In 1 kilometer, how many meters in a kilometer? 1,000, right. And then in a second, or in 1 hour, you might know how many seconds in an hour? 3,600, right. 60 times 60. 60 seconds in a minute, 60 minutes in an hour. 60 times 60 is 3,600 seconds in an hour. You should try counting them in class one day. We're not quite an hour, but you could almost see if you get 3,600 seconds in class. 1, 2, 3. But if you do this, you're going to get an answer that, what do we get? 10 over 1,000. If you do that, you would get 36 kilometers per hour squared, and a lot of you are going to put that answer, but it's missing something. It's missing that, and so the answer is not 36. The answer is C. You will have a question like that on the test. Maybe not on the quiz or not, I'm not sure, but you will have a question like that on the test where you have to do a unit conversion that includes powers. But if you know how to do it, it's easy. Right? That's generally true for everything, that if you know how to do it, then it's easy. I guess like that's not true in the gym. If you know how to lift 200 pounds, it still might not be easy, right? But in physics, it's true. All right. All right. Let's do this one, 20 cubic yards cement per hour. You have a good practice, okay, ladies? We'll be out in just a few minutes. Just give me a few more minutes, okay, folks? They have softball practice. Because we have like 12,000 softball players in our class, but I love my softball players. They're awesome. All right. 20 cubic yards cement per hour. And I want to express that in feet cubed per minute. We don't do British units, but you know how many feet are in a yard, right? How many feet are in a yard? 3. So in 1 yard, I have 3 feet, but because it's cubed, because this is cubed, I have to cube the conversion factor. Because in order to cancel out these yards, I have to have it cubed. So I have cubic yards canceling with cubic yards. And then the hour, I have 1 hour, 3,600, and that'll give me my answer, which is going to be 9. Okay? 9 cubic feet per minute. Oh, no, I'm sorry. I'm doing per minute here. This is not 3,600. This is 60. I don't think that's right. Is that right? No, that's right. Yeah, 180 over 6, or 20 times 90. Oh no, it's 27. 3 times 3 times 3 is 27. Yeah. Okay. So it's 9 cubic feet per minute. All right. Let's take a quick look. We're almost done. Let's take a quick look at the standards of measurement, and then I think that'll be all the different topics for chapter 1. Okay. As I said, you need to know the different standards. Like you need to know what are the current standards, and you need to know what are the historical standards. So, like for example, with the meter, it used to be a bar, right? Prior to that, it was what was it? It was like the diameter of the Earth, or part of the distance from the North Pole to the equator, like 1/10,000,000 or something like that. So it went from this Earth-based standard to an actual artifact, and now it's based on the speed of light. You need to be careful though. You have to know them pretty well because sometimes I'll mix up the words a little bit so that the standard for the meter might sound like the standard for the second. Because I might say, oh, the standard for second is the time that it takes light to travel such and such a distance. which isn't the standard for the second, right? That's sort of a mixing up of the standard of the meter. So just make sure that you know those. The standard for the kilogram, this is an old exam, but now it's based on the Planck constant. Okay, we talked about that. You need to know why standards of measurement are appropriate or not. They're accessible, they're unchanging, and they're, what's the other one? Accessible, unchanging? Accurate. Yeah, accurate, accessible, and unchanging. So why is it changing? You need to know the three basic quantities that we use in mechanics: mass, length, and time. You need to know why something would not be a good standard. We had a question like that today. And that's it. All right, questions, concerns? Yeah, Ricardo. Yeah. The Cartesian coordinate? Well, you'll have, that would sort of fall into the trig thing, where I would give you, like a question we had today, I'll give you the coordinates for a particular point and ask you for the r and theta. So it would just be a specific question discussing the ability behind r and theta. You remember that question from today? Let me sketch it out for you. So I would give you a Cartesian coordinate system, and I would say, look, I have a point right here. The coordinates are -3, 2, for example, and I would ask you, what is this distance, or what is that angle theta? And so that would be a Cartesian coordinate system problem. But it's really just asking you to, how do you know your trig? Because you got to use your trig functions to find those. Oh, yeah, so a Cartesian coordinate system can have 2 or 3 dimensions, or even 1 dimension. We won't use 3 dimensions till chapter 7 when we get into rotational motion. So no, not on this test. No x, y, z. There will be no z coordinates for a number of chapters. And then next semester we do quite a lot. We do magnetism. Taylor?
The stuff we did today is for the first exam, and then the quizzes would be the old exam system.
This stuff is, these, like you have all this stuff. It's on Moodle and it's also in the old exams. These are the questions that I'll pull from for the quizzes. Yeah. And the exams, I write those in here every year. So there'll be questions similar to these, but they're going to be different. Okay? That's why I put my old exams on, because I don't reuse the questions. Anything else? Feel a little bit afraid, but not a lot afraid. I smile and be happy. And have a good weekend. All right? See you guys. You're welcome.